Alright, hi everybody, and this is lesson A of Unit 8 here in Finite Math, and we're going to start off this unit by talking about sets, set notation, and some of the symbols that surround using sets. So what is a set? Well, it's just a well-defined collection of objects, and you can watch another video on the website that will describe that quite well. And these objects could be just numbers, results, or a list of items. For example, a list of items might be the list of states that border Iowa. So the 6 states that you see listed here that are inside these little braces, those are the states that border Iowa, for example. Wyoming, for example, would not be in that set because it's not a state that borders Iowa. So you usually define a set based on some common thread among the items. You might say like all even numbers, for example. So for our purposes in kind of going through some of these different set symbols, I'm going to call set A a set that has the numbers 1 through 5 inside of it. And I'm going to try to draw these braces as best I can. They're a little tough to get used to, but once you do, you're not going to be so bad off. Okay, so this symbol off to the left here, this is like a Greek letter almost. It looks like an epsilon. And that symbol rather, has a meaning of is a member or is an element of another set. So for example, I could say that the number 1 was an element of set A. And I'll use that capital letter to refer to everything involving set A. I could also say that 4 was an element of set A. So not surprisingly, when we get down here to the next line and it talks about this same symbol with the slash through it, is not an element of should be what comes to mind, because you probably remember from geometry anytime we've kind of put a slash through something that indicates the not. So for example, 6, the number 6 would not be an element of set A because it's not located within that set at all. Could also say the same thing for 0. 0 is not in set A, if I can get this to write itself here. So there we go. Okay. And then the next type of notation that we're going to run into is what's called this set builder notation. And it's just a different way of writing a set. So for example, you might have a set that has a very large number of elements. It might have a large number that are involved here. And this is the set builder notation. So you read this notation as the set of all x such that x has property P. Okay, now what is property P? That really could be anything at all. It could really be anything. I have to pardon my dog, he's scratching in the background there. So for example, if you wanted to write about a set, you could have like the set of all x such that x is even. You could get all of the even numbers in one fell swoop rather than taking forever to list them out. Or you might want to say the set of all y such that y is a multiple of 5, for example. And that'll cover everything at once, so that way you don't have to worry about it. This next symbol right here with the circle and the slash through it, that signals empty set. And the empty set is a very simple and easy set to describe. The empty set is a set with no elements. And you probably think well, that's kind of silly, but from time to time, it's rather useful to be able to describe a set that has no elements. And we'll run into that every now and then. The empty set is a rather interesting little character, probably my favorite set, as you can imagine. But again, in due time, we'll talk about it. All right, and then we've got this other symbol right here, which looks like a C with a line underneath, and we read this as C is a subset of D. C is a subset of D. So what does that mean really? Well, that means that everything that's in C is also in D, and D is a larger set. So let's just say that, for example, that we've got 3 sets here. The set C just simply contains 1 and 2 as its 2 elements. Let me clean that up a little bit. I told you these braces were kind of hard to write, and you know, sometimes they're challenging. See, there we go again. Okay, a little bit better. All right, and let's call set D 1, 2, 3, and 4. Okay, so I could say that C is definitely a subset of D because all of the elements 1 and 2 that are in C, they're also in D because D is a larger set with 1, 2, 3, 4. I could also conveniently talk about the set of 5, and we know it's not a subset of D because the element 5 isn't within set D at all. It's not even close. I mean, we're just not even in set D, so that's not going to work. Now, just a quick little aside about empty sets. The empty set is a subset of any set, whether it's D or C or A up above or anything else. So that's the basic idea behind subsets. Okay, quickly down here at the bottom, U is the universal set. That's the set of all given elements in a scenario. So, you know, a deck of cards is a really, really good example of a universal set. A deck of 52 playing cards has 52 elements, and each one is unique by suit, by color, by rank, and we'll get into that a little bit more in this particular unit. This last notation right here is the complement of a set. When you see this prime or this C superscript up there, the complement of a set, and in this case G. Okay, so let's just kind of consider our universal set to have the numbers 1, 2, 3, 4, 5, 6, and 7. Okay, and I'm going to say that G is a set that is going to be 1, 2, 3, 4, and 5. So clearly we know G is a subset of this universal set U. Now, if I want G's complement, I want everything that's in the universal set that is not in set G. Everything that's in the universal set that's not in set G. So the only 2 elements that are in set U, the universal set, that are not in G are 6 and 7. And those 2 are the ones that we'll call for our universal set. Okay. Now here's more of this set builder notation. For example, natural number less than 5. Well, you might know those as counting numbers. And you know, so the natural numbers less than 5, the counting numbers less than 5. If I wanted to write those out, 1, 2, 3, 4. And if I wanted to write these out, the days of the week that we have school: Monday, Tuesday, Wednesday, Thursday, and Friday. Those are the days of the week that we have school. Okay, so that's a quick little introduction into the sets and set notation. And in the next video for this lesson, we're going to talk a little bit more about the types of operations that you can do with sets.